Welcome back to Unit 9B Day 2. This is our second video. In the first video, we reviewed the word tangent. We got a new vocabulary word, secant, where we intersect the circle in 2 points. And then we talked about how intersections with lines and circles can happen. They can happen on the circle, they can happen inside the circle, or they can happen outside the circle. And that location of the intersection determines the formula we use to find the angles. If we are on the edge of the circle, we do just 1/2 of whatever this intercepted arc is. If we're inside the circle, we do 1/2 the sum of the 2 intercepted arcs. So we add them together, and then we do 1/2 of that. If we're outside the circle, we do 1/2 the difference. So we subtract. And you're always going to do the big arc minus the small arc because in geometry we have only positive angles. So we're going to keep everything positive. Let's look at some examples. All right, so we're going to find each measure and we're going to assume that segments that appear tangent are tangent. Okay, so I'm going to be able to assume that this segment here is a tangent segment. So what we need to think of is we talked about how these are working with lines. So if I were to extend this and say this is a line, and I were to extend this and say this is a line, I can see that my 2 lines are intersecting right here. And that intersection is outside my circle. Okay, so my formula for outside is the angle equals 1/2 the difference of the 2 intercepted arcs. Okay, so if I leave this angle Z, and as I come out, I can see I hit an arc here that's 80 degrees, and then I keep going out here and I hit this arc that's 160 degrees. This angle Z is going to be 1/2 the difference of these 2 arcs. So my big arc, 160, minus my little arc, 80. So that angle, I'm going to go ahead and call it measure of angle Z, is equal to 1/2 160 minus 80 is 80. So the measure of angle Z equals 40 degrees. This one also wanted me to find the measure of arc XW. So arc XW is the rest of that circle, right? If I look at XW, I know it's the short way around because it's only 2 letters, so if I have, it takes a 3rd letter to go the long way around. Okay, so it's the short way. I can see I've already used 80, and I've already used 160 out of the whole circle. My whole circle is 360, and I've already used 80, and I've already used 160. So in my calculator, I'm going to do 360 minus 80, which is 280, minus 160, leaves me with 120 degrees for this arc right here. Okay, let's look at the next problem. All right, on the next problem, it says to find the measure of angle FJE and the measure of angle FJG, and it says to find arc GH. Okay, so FJE, that's this angle here, and I know it's vertical to this angle here, so these 2 angles are the same. This is 45 degrees. Okay, FJG is this arc, or this angle right here. I know together on one side of a line I have 180 degrees. So if I used 45 degrees for this side, then I'm going to do 180 minus 45. This angle is going to be 135. So that together these 2 make 180 degrees, which means under here this would also be 135. And it's an angle, so we say degrees. And then the last thing we're going to look at is the measure of arc GH. So this arc right here. Okay, now it's kind of tempting to go, oh, it's 45. But it's only 45 if this were a central angle, if that 45 was this angle. But it's not, right? So it's not that 45 is not a central angle. So GH is not going to be 45 degrees. Okay? That 45 degrees is the angle inside. When we're inside, our formula says the angle is 1/2 the sum of the intercepted arcs. So if I think of this GH that I'm trying to find as an intercepted arc, I'm going to call it X because I want to find it. It's the intercepted arc for this angle right here, 45 degrees. So the angle is 45 degrees. It's 1/2 the sum of the intercepted arcs. Now I have two intercepted arcs because if I look on the other side of the 45, where the other 45 is, it goes out and intercepts the 28 degrees. So my two arcs are the 28 and the X. So all I have to do is add them together. Okay? All right, so now there's a couple of things we can do. We can distribute that 1/2, or we can multiply by 2. Personally, I like to try to get rid of the fractions if I can. If I distribute the 1/2, I'm still going to have 1/2 X, and I'm still going to have a fraction. So to get rid of 1/2, I like to just divide both sides, or multiply both sides by 2. Because watch what happens when I do that. If I do 2 times 45, I get 90. That equals this 1/2 and this 2 cancel each other out. And then I have just X plus 28. And all I have to do to solve for X is subtract 28. So 90 minus 28 is going to be that arc. 90 minus 28 is 62 equals X. And arc GH is what I was trying to find, 62 degrees. Okay? All right, let's look at another one. Number 3, my third example. All right, so this one's interesting. It says to just find the minor arc and the major arc. And I do know that this is the whole circle, and these are going to be tangents because my directions at the top said assume segments that appear tangent are. So these are points of tangency. And you notice I have 2 arcs that make up the whole 360 degrees. It says to think of the minor arc as X. So think of the smaller arc, which is always going to be the one closer to the angle. Think of that as X. And then your major arc, how would you find that? Well, if I knew what this was, let's say it was 100, okay, then all I'd have to do is take that away from 360 and say, oh, this is 260, because this is 100, and together they have to make 360. But I don't know how big this is, it's just some value X. So over here, what I would normally do is subtract however big this was. So I'm going to do that same thing. Sorry, there are people walking through the hall. I'm going to do the same thing for this side. So I'm going to do 360 minus X. And I don't know what X is, so I'm just going to leave it as that expression. Okay? So now I'm ready to try to work my formula. I just need to figure out which formula it is. My intersection is outside the circle. Okay, since my intersection is outside the circle, that means I'm going to do my angle equals 1/2 the difference. Outside is 1/2 the difference. So that angle I can see is 50 degrees. That is going to equal 1/2 the difference. And we always put the bigger arc in first. So my big arc, 360 minus X, minus the little arc, minus X. Okay? So again, the first thing I'm going to do is I'm going to multiply both sides by 2 to get rid of that 1/2. When I do that, my 1/2 and my 2 cancel each other out, and I get 100 equals 360 minus X minus X. I'm going to combine these two minus X's, right? And just say, oh, that's 360 minus 2x. I just combined my like terms. Okay, so if you want to see how I got the 2x, I just put these two together, and that's how I got the minus 2. Okay, all right, so now to continue solving, I need to get that the minus 2x all by itself, so I'm going to subtract this 360. Got to run out of room here. When I subtract the 360, I'm going to get a negative 260, and that equals a negative 2x. So negative 260 equals negative 2x. Okay, so now to figure out what just x is, I'm going to divide both sides by a negative 2, which is good because we want to have positives, right? These negatives are going to cancel. 260 divided by 2 is 130, so x equals 130. Remember, x was my minor arc, so my minor arc is 130. And then what's my major arc? Well, if this is 130 and my major arc is 360 minus the x, 360 minus 130 is 230. Okay, so my minor arc is 130, my major arc is 230. A big key to this one is calling the inside arc x and remembering that the outside arc is 360 minus x. So you'll end up with 360 minus x every time you have a picture like this. Okay, all right, let's look at the next one, number 4. The measure of angle QRS. So this angle right here. Okay, since it's on the circle, I know that the angle is 1/2 the intercepted arc. I don't have to add anything or subtract anything if I know this intercepted arc. Okay, the angle is what I'm trying to find. The measure of angle QRS is 1/2 the intercepted arc, but I don't know this intercepted arc, but I sure can't find it because all the way around my circle is 360 degrees, and I've already used 120, so I'm going to take that away, and I've already used 140, so I'm going to take that away. When I put in my calculator 360 minus 120, I get 240, minus another 140 leaves me with 100. So this arc here is 100 degrees. So that I get 360 degrees. So my intercepted arc is 100 degrees, which means the measure of angle QRS equals 50 degrees. Okay, let's look at number 5. We'll do number 5 and then we'll save the rest for the next video. Okay. All right, number 5, my intersection, angle R that I'm trying to find, is outside. Since it's outside the circle, my angle equals 1/2 the difference. So that angle, the one I'm trying to find, the measure of angle R, is equal to 1/2. So then I come out here and I go, where do I hit arcs? I hit an arc here, and then I keep going and I hit an arc here. Always put the big arc, the outside arc, in first. So 80 minus 40. Measure of angle R is 1/2. 80 minus 40 is 40. So the measure of angle R is 1/2 of 40, 20 degrees. Okay, all right, we'll do 6, 7, 8, and 9 in the last video for this section. Thank you so much for watching.